Welcome all to the webinar, A Practical Guide to the Urban Mine. Now I'd like to give the floor to Pascal Leroy, the project coordinator, FutuRaM coordinator.
Thank you very much, Eduardo. Ladies and gentlemen, thank you for joining us today on this important event as we mark a second significant step forward in Europe's materials policy landscape. The first one was the launch of the Urban Mine platform late last year. Today we will walk you through a practical guide to the platform. The UMP was developed by the FutuRaM consortium. FutuRaM stands for Future Availability of Secondary Raw Materials and is funded under the Horizon Europe program, reflecting the EU's commitment to secure sustainable access to the critical raw materials essential for our digital, green, and industrial transitions. Why do we run FutuRaM? The FutuRaM project was conceived to address a fundamental gap in our knowledge, the availability and recoverability of secondary raw materials, especially those considered critical for Europe's future. Most of the materials are locked away in products at the end of use stage, such as electronics, vehicles, batteries, slags, ashes, wind turbines, and demolition waste. Traditionally, information on these secondary resources has been fragmented or inaccessible. Without robust data, policymakers, industries, and investors are flying blind on the potential to recover, recycle, and reuse these key materials within the EU economy. FutuRaM aims to change this by building an open access, harmonized knowledge base so decisions on raw material recovery can be evidence-based, helping the EU move closer to its strategic and sustainability goals. What policies and programs govern CRMs? The EU has recognized the strategic importance of critical raw materials through a range of policies. The most notable recent step is the Critical Raw Materials Act, adopted in 2024. The regulation is designed to strengthen Europe's industrial sovereignty, support the circular economy, and reduce vulnerabilities in supply chains. Member states are now required to develop national resource programs, improve supply chain monitoring, and support strategic projects for extraction, processing, and recycling. Complementing this, the United Nations Framework Classification for Resources, UNFC, helps harmonize assessments and viability of raw materials projects across regulatory, economic, technological, and environmental domains. How can the Urban Mine platform help? Today, the FutuRaM consortium proudly launches the platform, a groundbreaking online tool that delivers detailed projections on the availability of CRMs up to 2050, covering major waste streams such as batteries, vehicles, slags, wind turbines, and demolition waste. By offering harmonized, structured, and accessible data, the platform empowers manufacturers, recyclers, investors, and policymakers to design and implement recovery projects with confidence. It supports strategic planning to increase recycling rates, diversify sources, and ultimately strengthen Europe's material independence. Most crucially, it operationalizes the concept of the urban mine, turning Europe's waste into a resource base and helping close the loop in the circular economy and advancing the objective set out in the CRM Act. FutuRaM and the Urban Mine platform embody Europe's resolve to ensure secure, sustainable, and responsible access to critical raw materials. By bridging the data gap and aligning with robust policy frameworks, they provide a cornerstone for the next generation of resource management, making urban mining part of Europe's strategic arsenal for a truly circular, resilient economy. Join us in exploring the Urban Mine platform and what it could mean for you and your business. Thank you very much.
Thank you, Pascal. So now we will explore the Urban Mine platform. I'd like to give the floor to Daniel Lefort. Daniel.
Yeah, thank you very much. I will share my screen, and if you want to test, you can go to www.urbanmineplatform.eu. So just excuse me 1 minute because up. Partage. Sure. Okay. Can you see my screen?
Yes, just not
Okay.
in presentation mode.
No, it's not presentation mode because it's my
Mhm.
it's my navigator. I will make it a little bit bigger. Okay. So that's the main page when we click urbanmapplatform.eu. So, for example, if you were users of previous version until last year, so it's the same URL. So now it's the same domain. So urbanmapplatform.eu. Meanwhile, now we have a new security thing. So maybe some links are broken before compared to previous portal. In any case, there's the website UMP Urban My Platform, your gateway to data on secondary and critical raw materials in Europe. We are accessible since November, visible in navigators, research motors, etc. etc. So that's the main page, and you have here 7 logos of 7 waste streams that we considered and we assessed in this project in FutuRaM. So I will give you an overview of the facilities and how get data in different ways for these 7 waste streams, and later I'm going to show you other possibilities. And also I want to say that this development of Urban My Platform is still not fully finished because the project is still running until May. So we are going to incorporate new things, for example, fact sheets and new possibilities. So this website is a live version, so until May. So we are not everything is still there. So once we have this main page, we can simply select the first waste stream, and we are going to open the website for example, batteries. We are following in all the cases the same structure in general. So we have batteries here. We can navigate across here and go to other waste streams, but we are going to be here in batteries, and we access directly to charts. In charts, we are going to see what is in charts and what are the possibilities of filtering data in charts. We have also possibility of Sankey diagrams, and we have here scenarios, and I will show it to you later what are scenarios. But here just a quick overview of what is in general, and that's the structure that we are following in all the cases. That we are first displaying new batteries put on the market, so that are the batteries that are being sold or put in the market from 2010 until 2015. And here we are displaying data for the entire geographical scope, so EU 27 plus 4. And data is here displayed in terms of the main battery types. I can apply just a filter, for example, for a country, and I'm going to apply to display only data for one country, in this case, only Belgium. We have the possibility to display new batteries put on the market, where there is an explanation with the main hypothesis. That is a short text. Stock of batteries as well, so that are the accumulated stock of batteries, in this case in Belgium, until 2050, and we can have the same in terms of waste generated from batteries. That's batteries going in end of life. As you know, batteries is not only vehicle. Batteries is batteries embedded in electronical equipment. that can be battery, industrial batteries, etc. And that's here. Sorry, here we have the different types of batteries that we are considering. For example, batteries in mixed municipal waste, batteries electrical vehicle, batteries in cell phones, cameras, e-bikes, energy storage, etc., etc. So you can select, for example, only batteries for one product, so laptops, and we are going to display, in this case, the amount, but only in Belgium, and batteries and laptops. Put on the market stock of batteries and waste generated from batteries. And we can see that when selecting one category, in this case laptop, we have only two chemistries of batteries: lithium-based batteries rechargeable and nickel metal hybrid-based batteries, which has a very, very small market share, and the amount of waste from this type is very, very small, and is almost zero now in 2040. So that's there is a unique technology, lithium-based batteries rechargeable in laptops. So I'm going to show you all the possibilities of filtering with other waste streams. I don't want to go to show you all the possibilities of filtering in all the waste streams, because I think it's quite repetitive. But the last possibility of displaying data is that we can compare here scenarios. So we can compare here the waste generated in Belgium for this category, the waste generated for business as usual, waste collected for recovery. So here, sorry, exactly. We have total waste generated. That's the line, this line. I don't know if you can see my screen, my screen, the screen, and we have waste collected. So waste generated was bigger than waste collected in laptops. If we go to Sankey diagrams are not proposed for one country, because recovery recovery, for example, in battery, there are movements between European countries, etc. So we decided to display a Sankey diagram at EU 27 plus 4. So in Sankey diagram, we have only two options to filter. So we can select one year, and by default, I think that, yeah, we display reference year, which is 2026 is current year, and we can also display a Sankey for one material. In this case, it's aluminum, but I will select, for example, cobalt. So I'm displaying a Sankey diagram, which is very rich, and I know that labels in some cases are a little bit complicated. So if you want to see better labels, you need to play a little bit with the options, dynamic options of the graph, for see the names of different options in this Sankey diagram. So that's at EU 27 plus 4 batteries, and cobalt in batteries, all type of batteries, and we have different. So we are starting from battery generated, different treatment options. So for example, here we are going to combination and separation. At the end, there is a big part that is going black mass for export. There is a part that is going to hydrometallurgical processes. And later we have also, of course, in all industrial processes, we have losses. That's for cobalt, but we can select any other material. And what we can also select is scenarios. And in scenarios, I will explain later, but certain hypotheses of scenarios makes that we are more optimistic in the recovery rates. We are more optimistic in collection rates of waste, and scenarios makes that change. We are changing the numbers in these Sankey diagrams and also the part that, for example, is going to losses. And in circular, that's in recovery. And in circular scenario, it's a scenario with more circularity, with more reuse, with longer lifespan of products. So that means that we are going to have a reduction of certain waste and because we have longer lifespan of products. And that's maybe not very visible in Sankey diagrams, but it can be easy to display in other charts. The idea, the evolution, is that we are going to add a third menu here, which will be fact sheets, where we are going to display essential charts, essential numbers of the main results, for example, in this case of batteries. And we are going to have three possibilities to display data: charts, Sankeys, and fact sheets. In fact sheets, there will be no many options of filtering, but just we are giving you the main results for this waste stream. So I'm going to change to another waste stream. So I can go here. So I can go to building. In building, we can see that the options of filtering data are not exactly the same, and we work it at here at U27. The geographical perimeter is not exactly the same in all the waste streams for different reasons, mostly technical, and data accessibility is easier. So we have the same structure here: new buildings put on the market, building stock, and demolished buildings. In buildings, colleagues from Leiden University that work on buildings, they work in building surfaces, and they also work it with a mass, so tons of materials in buildings. So it's in this waste stream we can display certain things with both units, surface and mass. You are going to say, there is here a big difference in 2010. That's probably a modelization or artifact, I will say, that it is being explained later because in our waste streams we have also two possibility that if you want to know more, read more, you click here and you are going to have access to a document that it's explaining the methodologies, the vocabularies, and main hypotheses, and also, and I think it's also important, they are explaining also, for example, limitations and recommendations. So, and also giving access to additional documents. So I'm coming back to the website. So that's on buildings. So in buildings we have the same as in batteries, but we can only filter non-residential and residential buildings, and we can select here directly a material, let's say aluminum. I chose it here, aluminum, and as element, and aluminum at the end is mostly only found in aluminum alloys, and you can have also aluminum in copper alloys. So, but let's say I am only displaying aluminum, and I will select, for example, a country. I will change. I will go to France. So here that's the amount, the input of aluminum as element in buildings in France every year. That for a business as usual scenario, but we have also for a recovery scenario where the number is exactly the same, and in circular where there is a small reduction because we are in a more circular economy. I'm coming back to business as usual. So we have put in the market, so new aluminum, that's the stock of aluminum in buildings in France. And you can see that we have the stock of non-residential is quite important because we have more windows in non-residential buildings such as offices, schools, and hospitals and those things. So here we can see that there is a big part of aluminum which is in non-residential buildings in the stock. And later we will see an hypothesis of demolished buildings. So that's the outflow, that's the amount of tons of aluminum being wasted in this scenario, business as usual, until 2050. And we can see that in a circular scenario, there is a reduction. There is an increasing of waste, but it's not the same amount. And here we can see waste generated, that in this case, we are only displaying waste generated. If you want to download the data that is being used for this graphic, for this plot, with those three small dots points, you click here and you can download in PNG, for example, and you can download also in Excel file. So in this Excel file, we are going to download the numbers for business as usual scenario in France, aluminum from 2010 to 2050. And with that, you can use that. We have another option to download all the results, but I will show it to you later. So that's for buildings. In buildings, we have also the possibility to display Sankey diagrams. In this case, the Sankey diagram is less complex than in battery. That's for example, for aluminum alloys, so we can keep it. And we have here that CD waste collection and CD waste here distribution there is no losses here, but after CD waste distribution, a large majority of aluminum is going to recycling, which is good, and we know that aluminum is very well recycled. And there's certain parts that are a little bit lost, mixed with energy recovery. But we know that we are not going to do energy recovery with aluminum, but there is a part that is lost with that, and a part that is going to landfilling. But the large majority here is going to recycling. That's in circular scenario, same in recovery scenario, and in business as usual scenario. In business as usual scenario, we have also maybe a small part that is going to backfilling. We can display that for other materials. For example, copper alloys, it's the same. I'm going back to another waste stream, mining waste. And in mining waste, we are displaying things in a completely different way, because in mining waste, we are not displaying stock and flows, because it's by definition a completely different thing. And in mining waste, we are displaying here historical mining waste sites in Europe. And we display that's the result of a collaboration with all the geological surveys in Europe. That geological surveys in Europe, they are also working on that in another project, which is called GCU. And geological surveys in Europe, we are together for those topics about mineral resources for a long time. And we have also now a certain obligation in the framework of Critical Raw Materials Act to made available data sets about mining waste in Europe, historical mining waste in Europe. So what we are displaying in this map? In this map, we have the collection of national inventories of member states in Europe, but also outside European Union, because we have data, for example, in some countries of the Balkans or Ukraine. And each point is representing a mining waste deposit. So a single deposit. And if I click in any point, I'm clicking here for Finland, we can display this mining waste site. It's in Finnish, so I'm unable to pronounce it correctly. I have the coordinates. It's a mining waste in type mineral excavation and metalliferous excavation. And here what is interesting for us is that I have data about the amount of waste. But in this case, I don't have ore grades. I have only oh no, yeah, sorry. In this one, I have only the tonnage, but in this one, for example, I have the total amount of silver, zinc, the grade of zinc, and the grade of copper, for example, in tonnage and in grades. So here we are giving for each point in this map uh, information about the localization of those mining waste, the volume or the area or the tonnage. It depends. Not all the countries we are delivering the same information, and we are also having information in terms of tonnage, so the total amount of one substance, the total amount of copper, the total amount of zinc, the total amount of silver in this waste side, and or in other cases we are not giving the tonnage total, but we are giving the ore grade. So for example, I'm going to click in another. That's our data in France. So that's Prelof in Brittany, and we are mostly giving volume of this waste and the grade of certain substances that were measured here, where mostly the main one is lead, because it's all lead mine with still an important 6,000 ppms of lead in this mine. But we measure it, for example, a small metals like, for example, indium and those things, and we can see that the amount is quite low in terms of ppms. That's the type of information that we can find. We are working to make this table more accessible and more user-friendly. That's something that we are working on to that. And we are also going to, this database, this data set of mining waste will be the same that is going to be disclosed in Geological Service for Europe, and a portal that we are sharing also with colleagues from with the Geological Service in Europe. So that's the data that we can access now in FutuRaM, in UrbanMap platform for mining waste. So it's the only data set where we are displaying a map instead of charts of flows. If we go to slags and ashes, so slags and ashes in FutuRaM is a big category mixing many different things. So slags from metallurgical processes, slags from steel industry, copper, etc. We are also having bauxite residues, and we are also including bottom ash from municipal solid waste incinerators, sludge from water treatment. It's a big category, and we can display here all the things that we are covering. So for bottom ash from different biomass incineration, we have coal fly ash, slag from copper, lead, and other metallurgical processes, fly ash, and red map slash from zinc metallurgy, and slags from different steel production methods. So it's a big category mixing many different things, I would say. So for example, we can select only one. So that's I will select the two main types of production of steel that are generating slags. So slags is a sort of a waste that is being generated during the production of steel. And here we are displaying basic oxygen furnace and electric arc furnace. So both main types of production of steel. And here we are not displaying put in the market and stock, because it's a waste that it is related to a production process. So we are only having data about the waste generated every year. And the production of steel slag is the result of the production of steel. So we are based on past 10 years of production of steel. We are seeing that the production of steel has certain fluctuations, and the scenario is just applying a certain stability until 2050 in terms of steel production and consequently slag production. So that's for business as usual. For recovery, there is a certain change, but in recovery, what we can see is that we are going to reduce the amount of basic oxygen furnace and increase the amount of electric arc furnace. Why? Because electric arc furnace is mostly the methodology for steel recycling, and basic oxygen furnace is mostly methodology from primary ore. So in this scenario, we are recycling more and producing less steel from primary ore. So that means that we are changing a little bit the distribution of two types of slags. So we have here slag generated, and we have also this plot which is only displaying slags and ashes generated in 3 scenarios. So we have here recovery business as usual and total waste generated. I can select here one element. So for example, we can decide to only display one element that it is measured here, and that's one element that it is presently in a certain quantity is important, vanadium, for example, and that's the amount of vanadium that is supposed to be embedded, contained in the slags and ashes that are being generated every year in Europe, associated to the production of the steel. So that's the vanadium that is being contained in slags, so the waste of the production of steel. Here the Sankey diagram is still not available, but we are working on that. Next one, so vehicles. So it's quite repeating process, but we have new vehicles put on the market in tons here with different types of a typology of vehicles. So battery electric vehicles, natural gas vehicles, diesel vehicles, hybrid vehicles, etc. So we can see here that the market shares of different technologies are changing a lot. We can see that following also the regulation, battery electrical vehicles put on the market must be fully after 2014 in this case. And yeah, same options of filtering here. So we can filter by one country, product. So products are the types of vehicles that I'm displaying. At components, so here we can, for example, okay, I want only to display data, for example, about traction motors permanent magnet. I think that can be interesting. So I will only display traction motor permanent magnets as a component in vehicles. So that's the total, the mass of permanent magnets in traction motors put in the market. So we can see that it's mostly associated by definition to electrical or hybrid vehicles. So that's the put on the market. That's the stock. The stock is starting to become more and more important with the deployment of e-mobility. And we can see also that consequently and a little bit delayed with the lifespan of products, this flow of permanent magnets in traction motor is going to increase after 2035. There is a certain, it's becoming more and more important, this flow. And I'm not here, we are displaying this data set in terms of the mass of traction motor permanent magnet, but we can select directly to the amount of neodymium in traction motors. Same possibility, we can also display it for only one country. So that's the case for Belgium. And we can download this dataset as well. I will go to next. So yeah, with I didn't say, but we can reset filters in general, and we can start again and display other things. I will go to next waste stream, triple E waste to V. So here, same, new EE, triple E put on the market, stock of EEE, and waste generated from triple E. So here, once it is waste, we can put the W and we can call it we. So, and for we have 7 categories. So lamps, large equipment, excluding PV panels, screens and monitors, small IT, small equipment, and temperature exchange equipment. So that are the categories that are in the WE directive. There is a discussion about the evolution of WE directive, but the evolution of WE directive is still not there in FutuRaM dataset. So well, we can display. I will not select a country, but I will go only to so for example PV panels, and I will select for example aluminum alloys. The frame of PV panels are in aluminum. So for example, I'm interested only in aluminum in PV panels. So I will apply this filter. So that's the put on the market. We can see that there is a big increase in the deployment of PV panels in Europe in general around 2023. So that's put on the market. So that's the new aluminum in PV panels every year. That's the stock. The stock is increasing, and it is increasing as aligned with a certain scenario, and those scenarios in this case are aligned also with certain climate and energy transition scenarios that are also linked to European objectives of deployment of PV panels. And the waste generated consequently is not following the curve of the stock, but a little bit. No, we have an increase, and it is increasing every year the amount of aluminum alloys contained in PV panels that are going to be wasted every year. We can select another, for example, same. Go directly to components, for example, and components in this case that can be printed circuit boards, which is maybe one of the components more interesting for the recycling sector in general. We can apply a filter, and we can see also, yeah, that's I'm hearing waste generated, so we can see that in Europe, 27+4, the tendency of printed circuit boards, PCBs, the tons of PCBs in waste for different categories. So we can see that small equipment, small IT, and screens and monitors, and large equipment, excluding PV panels, have a big contribution. A small contribution, for example, of PV panels. So PV panels don't contribute to that. Lamps, neither, etc. So, and we can also select, if we want, an element embodied in PCBs, for example, copper in PCBs, and we can display only copper in PCBs. And we can also display Sankey diagram. And Sankey diagram, once we are going to Sankey diagram, we are completely losing previous filter options. So here I am in aluminum, but I can display, for example, copper, the copper Sankey diagram. We collect it for treatment, dismantling, and depollution. And there is a part that is going to a further but undefined recovery option. Later there is shredding and separation, and there is a part that is going to smelter. That's the part that is going effectively to a recycling smelter, and there is a part that is going for landfill or dissipated. So that we can see here in a business as usual scenario currently, which is more or less the copper recovery Sankey in we all the we together. So we have the 7 categories of we together here. So I think that maybe I'm a little bit out of time. I will go to the last one, wind turbines. So is a category that we consider it differently in FutuRaM because it's not exactly a building. Maybe will be under the new WE directive, but when we started the project, we didn't know that. So in wind turbines, same approach. In wind turbines, we can measure wind turbines also in megawatts because at the end we are counting the capacity that we are installing every year. So new wind turbines put in the market, stock of wind turbines and dismantled wind turbines. And in wind turbines, we use a typology of wind turbines that is being used by several international reports agencies, public agencies, and where we have important differences in terms of the use of certain materials. You know that in wind turbines, one of the main questions is the use of magnets, permanent magnets, and the use of radars. So I'm going to, for example, select here that I will only display offshore. You know that permanent magnets are being used in certain technologies of wind turbines, but for offshore wind parks, permanent magnets are have the largest market share, and we are all the time using permanent magnets for offshore wind turbines. But we are using also permanent magnets for onshore ones. I select offshore, and I will go directly, for example, to display radars. So I will take neodymium and dysprosium. So that are the main two rare earth elements that we are using. So that are the put on the market, new wind turbines put on the market, but here it is in terms of tons of neodymium and dysprosium. The stock of those two rare earth elements in Europe 27, and in terms of dismantled wind turbines. So what we can see is that in terms of the amount of neodymium plus dysprosium in Europe, until 2035, it's nothing, but it's a small amount, I will say, but with the dismantling and the decommissioning of the first installed wind farms offshore in Europe, mostly I'm thinking in Germany and in Denmark, we can expect an increase of the amount of this waste in the future. And same, we have also the possibility to display Sankey diagrams for different elements. And last but not least, we have, and that's new compared to previous Overmind platform, is comparison. And comparison is a way that we are still working on that, but it's a way to compare waste flows. Mining waste are not in this comparison because it's a slightly different thing, but we can compare, for example, here, the total amount of waste. If we are putting everything together, CD waste is the big part, and that's not a surprise. And later we have slags and ashes. But I think it's more interesting maybe to, for example, go to only select, for example, copper alloys. And in copper alloys, we can see that things are slightly different, where there is a big contribution of we have also wind turbines that are important and buildings are important. We should say that in buildings, we are not considering industrial cables and power network and those things. We are just considering buildings. If we consider maybe those things that are not infrastructure, and maybe the thing will be different. will be different. But we can see that in copper alloys, there is a big contribution of those three waste streams. And that's per country, and we have also a comparison here for 3 years, 2019, 2030, and 2050 for buildings, wind turbines. So we can see also that here, and that's for one scenario, but I can change of scenario, and I'm going to change the result of it. Not working. So that's the evolution of also for three temporary years. So three different years. So we can see also the evolution. What is the interest of that is to see that in e-waste and buildings there is a slight increase of this waste, but more or less same order of magnitude. Whereas in wind turbines, where the current waste of copper alloys in wind turbines, because we are decommissioning now very few number of wind farms, so the amount currently is very low. But in the future, with expected decommissioning of oldest wind farms in Europe, we can expect that this value is going to increase in the future, in 2030 and in 2050. And in comparison, we are going to have this part of comparison will contain more information in the future. We are still working on that. So that's all from data displaying, but also we put in place an option to download all the data. We have certain data sets that are already available for public, and there are certain ones that are not yet publicly, not because of things of confidential or whatever. It's just because we are working on scientific articles as well. We are a research project, so we want to keep it in a certain embargo for that, to give us the time to publish and finalize those articles. So for the instance, you can download e-waste, slag and ashes and buildings, and vehicles, batteries, and wind turbines will come. Will be made accessible in the future. Also, it's important also to have in mind other parts of the website that we are explaining also about the reason of our project, who we are, etc. And also, we have three important things, I will say. Legal protection, so legal notice, but which is the origin and the provider of those things, the number of the project, etc. That's very legal thing. It is important also. Maybe it's not very visible for the instance, but if there are any questions about the content or whatever, or problems with accessibility to certain things, there is a web email that has been put in place, ump@futuram.eu, and we are different colleagues from the project that we are receiving those emails. And I think it's important, because if there is any question related to UMP, we are going to have those emails, and we are trying to answer you as soon as possible. That's it's important also that we are seeing it's Creative Commons Attribution 4.0 international public license. So you have also a copyright notice. I think is also important. Data protection, it's a website that we are not collecting data, and it's GDPR compliant, etc. And copyright, I mentioned already that, but I think it's important. Maybe if you want to cite our work, or if you want to refer to this work or whatever, here we propose you how to cite the Urban Mind platform, and I think is very useful for you to cite that. Even though individual data sets, you can also refer to other deliverables of the project or the scientific articles that are being associated to that. So I think that I give you a quite global overview of the Urban Mind platform. That's the result of the work of many colleagues inside Bergem, so the French Geological Survey, where that we developed it, the IT system. So I want to thank you, my colleagues that participated to the development of this portal, and also the colleagues from the entire consortia of FutuRaM that provided the data sets of all those waste streams that I show it to you. It's a collective work that at the end is made it available through this website, Urban My Platform. So thank you very much.
Thank you, Daniel. And thank you for your demonstration. We have some questions in the chat. And if someone would like to also speak, you can raise the hand. The first question is if you can provide a source of data.
The source of data. Well, the source of data, it's something that you can have access to that in these read more documents, and we are also referring to the deliverables of the project. I think it's important. This Urban Mind platform dataset is associated to a set of documents that are the deliverables of the project that are explaining the methodology and the source of data. And in those documents, you can find which are the raw data that has been used in terms of composition, waste composition, and in terms of statistics to model those waste flows from now to the future.
Okay, thank you. And then a comment, hard to see which is the country selected and which is the element selected. I think it's because when you select, appears one selected and not the material in specific.
I can share again. Sorry. I think, I understand the question. Where is this? Sorry, I lost my, okay. Yeah. Normally, so I will go there. So in buildings, if I'm selecting a country, Belgium, it appears here. So it is here, it is selected, but in the graphic, it's not selected. It's not,
Not shown.
I understand the question. So it's
As
not
the
shown
element.
and the elements. So for example, I'm selecting, I don't know, copper. In the graphic, I'm not displaying that it is Belgium and copper, but here we have that it is Belgium and copper. So yeah, that's something that we need to be aware because explicitly in the graphic it's not appearing. Yeah.
Okay. Next question is how do we add more mining waste sites? For instance, in the north of Portugal, there are a lot of old WO3 mines, uranium, and oil.
Well, that's it is the responsibility, and now it is in the law of Critical Raw Materials Act to all the member states in Europe must update databases of mining waste. So even we in France, we selected a certain amount of sites where we had enough data, and we are working on that. It's a living database, so it's not a screenshot. So it's a database that it is being connected to national databases. So, for example, in Portugal, we can imagine that LENEC colleagues we are going to update this database. Same for us, Bergem, and we are also having that several countries are not present, but I know that they are working on that. So yeah, it's a ongoing process. that will live after FutuRaM because it's by law.
Okay. If we want to filter to find a specific material waste, can it be done?
I don't understand the question.
Think
So
maybe another material that's not shown. It's from Beatriz. Beatriz, if you like to speak, please raise your hand and we try to clarify.
because the thing is that each waste stream uses a certain terminology of materials and components, etc. So because it's quite specific for vehicles, it's not the same thing that for etc. So there
I'm
is
unmuted.
yes.
Oh, hi. No, my question is, for example, if we want to select, for example, just cobalt to see where in where we have the mines or the waste or any other kind of material, can we select per material where we could find
Yeah, in
more available
comparison.
stock? Yeah.
In comparison, you can select only cobalt and you display cobalt and where is cobalt in different waste streams, but in a very aggregated level. Later, if you want to work more on that, yeah, you need to download certain data sets. But for example, you can select in comparison module. So yeah, I will share again. Sorry. I will not stop sharing, I think. For example, I'm going to waste stream comparison. So I can select cobalt. And well, it's no surprise, a big amount of cobalt in batteries in we and it's like an ashes. But well, the degree of availability of cobalt in batteries and in we is not at all the same than in slags and ashes. In slags and ashes, it's quite disseminated. Huh? So, and later, if you want to inside, for example, batteries, you need to go to batteries and select directly cobalt. And you are going to see where is cobalt. And cobalt, once again, is only in a large majority only in lithium-based batteries, rechargeable. In the other type of batteries is a small amount of cobalt. That's so yeah. You can find this data, I think, between comparison and inside different waste streams.
Okay. Thank you.
Yeah, you're welcome. You're welcome.
Next question is do you know if technology like to green hydrogen production, namely electrolyzers and fuel cells, are under the scope of WE directive and therefore a potential source of recovered elements?
They are not in the WE directive right now. I think that they are not really in the evolution, but maybe my colleague Kis Valde, maybe you know better than me the evolution of WE directive. In any case, it's something that we didn't cover in FutuRaM project.
No, this evolution of the WE directive is not covered in the FutuRaM project, so we wouldn't have any data on that. I think the real answer you would have to ask the European Commission, although likely this could be covered in the WE directive, although I wouldn't know for certain. The scope is being extended, and the exact definition of the scope is I can't disclose more on that, right now. So I think that's a very good question to ask to the European Commission.
Question: when will the UK case study for we be published?
Yeah. I can maybe feedback on that as well. I think this refers to the UFC case study which we've done at the United Kingdom. It will not be published at this platform, but in a separate deliverable on the UFC case studies. And I've also seen that colleagues are preparing a scientific paper about this. So it will be available from the FutuRaM website and
Yeah, the deliverables of the project and scientific content are in the website, official website. So it's futuram.eu, and here you find the deliverables, and certain ones are still not there. So but because we are waiting for the approval of the commission for certain things. But yeah, for those type of documents is mostly to the official website of the project, not Urban Mine platform.
Okay, I'm leaving the link in the chat. I think the last question for now in the chat is, can you say which is the country selected and which is the element selected in order to download figures for reference purposes?
I think it's similar to the question before.
It's from the
So,
second person, yeah.
so for example, I'm going here and I'm selecting a country and an element. When I am downloading it, yeah, I'm not having, okay, yeah, I understand. We are not having the name of the country. So here, when I'm downloading that, I don't know that it is Austria and antimony. So okay, yeah, it's maybe a good point to maybe
Can it be done?
discuss.
Mm.
We discuss with now, for instance, now there is not, but it's good. It's good to have those feedbacks that maybe we can try to yeah. As I said, we are still in a active way, so
Improvement.
we can. There is place for improvement of those things. Yeah.
Yeah, thank you. We don't have more questions in the chat for now. I'd like to share a small questionnaire, less than a minute to fill in about your feedback on the Urban Mine platform. And meanwhile, you can raise your hand if you like to, if you have more questions. Can you see what QR code? Yeah. Someone else want to ask something? Any doubts, any questions?
Did you answer the questions in the Q&A tab, Eduardo? There's 3 questions in the Q&A tab as well.
Okay.
Yeah, I'm seeing that. So other EU languages, no, it's not planned for now. How are the sources from data? It is holistic or just representative? Well, that's referred to what I said before, that you need to refer to scientific and deliverables documents. So it is based on it's a hybrid of combination of official statistics of certain or industry reporting, I will say, plus a huge sampling and material composition work, and that's the work. So that's the answer. And Luke, so I have plotted neodymium, etc., which are available in all categories, but on slags and ashes I found rare earth elements. What is the difference with neodymium, praseodymium, double count or more large? Need to check. No, double count, I don't think so. I think that in Slack and Ashes, they didn't consider it at element level, whereas for example, in with Darwin's and in with Darwin's, we consider it at element level. And also, yeah, that's a certain complexity in Slack and Ashes case study is that we have enormous amounts of waste because that are big amounts of waste, but with several the content, for example, of radars is quite small. We know that, for example, there are certain radars contained in bauxite residues, but yeah, if we are comparing that to radars in magnets, the concentration is not at all the same. So, and that was a little, it's a certain complexity when we are comparing those things. But I will check with colleagues as well. I think that there is no double count. It's a different way to model it in different ways streams, but need to check. Good question. Thank you, Luc.
I don't think we have more questions. Nope. Okay, the comment. Thanks and great job. So
Okay.
I think we have another QR code to share about the FutuRaM final event. Keith, would you like to share or give a word?
Well, thanks a lot for all your comments. I have nothing to add to this from a content, point of view. We'll consider your feedback in the remainder of the project, and I would like also to mention to you that we are working towards finalization of the project, and we will be having our final event in Brussels on May 27th. I don't know if someone could and if you would like to be part of that, in which we will, of course, present the project findings, plus also not only the DeepMind platform, but also the final report and the UNFC case studies and the work done in the entire project. So if you're interested in to attend that, you're also welcome in Brussels on the 27th of May. Is there a QR code which we could share for those of you that would like to register there? I was supposed to get a slide, but I didn't see it in my mailbox yet. So
There's
maybe
a link in the chat.
there's a link in the chat. That's even better.
To the Ticket Tailor site to register for the final event on the 27th of May.
Yeah. It's for free, right? It's not. It's
Yeah.
ticket is not gonna...
Did you see it? Yeah.
Yeah, this is excellent. This is what I was looking for.
Here,
Thanks
the
a lot.
final event registration link.
And with that, I would like to close today's webinar, and also thanks a lot for attending, and hope to see you all in person in Brussels at the 27th of May at the Novotel Hotel. Thank you.